Hello, everyone. Welcome back. Hope you guys are doing good. Just about to start in 3 minutes or so. But until then, welcome. Good to see you, and just get comfortable, and we'll get going in a few moments. Feel free to say hello or anything else, and I'll see you guys in the chat. Hello. Hi there, Valeria, John Reb, Leo. Good to see everybody. Hi, Brenna. Hey, John Reb. Samir, I hope you're able to send your homework. But like I said in the last message, worst case, you could just type it into the actual email if that's necessary. How do we translate P, in which case Q? What do you think? Take a guess. Okay, thank you, Samir. And everybody else, good to see you guys this morning. Well, your statement, though, John Reb, P, in which case Q, that does not correspond to what was written in the problem, which said, in which case he will win the presidency. Because the whole preceding statement was the thing claimed as. So anyway, though, in which case expresses a conditional. So if you've already spoken about some fact, and then you say, in which case, like if I fall off my bike, then I'll have to go to the hospital, in which case I won't turn in the homework. So what's said there is that if you fall off, if you go to the hospital, then you won't turn your homework. Okay. Yeah, Yvette, so just about that, I've confirmed all the submissions that I've received as of 9 a.m., but I've been teaching and doing some office tasks since 9. So to anybody who has just submitted in the interval between 9 a.m. and now, you're going to get that confirmation email before 1:30. After I finish with this class, I'm going to go through the queue of emails in the inbox and just send confirmations to all those who've sent them. So yeah, not to worry. When did you send yours, Yvette? If it came in just now, then that's the reason I've not yet quite gotten to your confirmation. But hopefully that's so. If you sent it earlier than that, let me know, because then there could have been a problem. You'll let me know in the chat, right, Yvette? Hi, Nathaniel, and everybody else. Okay, guys, so it's 11:30. You sent it at 8:40. It might have just been right before I stopped looking. Here, I'll give you direct confirmation right now while I'm talking to you on this live stream. So 8:40 a.m. Sorry, this one's not the right inbox. All right. Yeah, I guess actually my last responses were given prior at like 8 a.m. So as of 8:09, then I have not done responses, but I see yours, Yvette, at 8:40. Yes, it's there. So to all submissions that came as of 8:09 or on, they're in my inbox. I just have to send a confirmation right after this class meeting. Okay, so not to worry, Destiny, I also saw yours, yes. Okay, thanks everyone. As you all know, I was just mentioning that today the second homework is due, so you should have already sent it to me. It should be in my inbox now. To those that I received before 8 a.m. this morning, I've already given confirmation to everyone, but for anybody who sent it this morning between 8:09 and 11:30, I'm going to get to your confirmation of receipt in the hour after this class meeting, so not to worry about that. But anyway, you're all done with the second homework, so good job. Now we just look forward to the midterm next week and finishing a little bit more material on this chapter 3 stuff about truth tables. So we have 2 class periods this week where we will go over the last few truth table concepts. And then on Monday, we will have a review session. I'll give you guys a study guide over the weekend so that you can come in prepared to the review session. And then next Wednesday, we'll have the test. In between now and next Monday, I'll be grading your guys' homework that you just handed me. So you'll get the grades and you'll know where you stand on everything before the review session on Monday next week. So that's just a couple of basic updates. All right, everyone? Now, as we've done a couple of other times, I wanted to do a dual platform meeting here. So for the sake of having a record of the recorded lecture, I'm going to have this YouTube recording playing through. And I'm also going to provide the link here in our chat for a Zoom meeting. And in the Zoom meeting, I'll be able to share screen and stuff and show you guys some of the problems. So that'll make more efficient use of our time, so I won't have to draw necessarily everything to display the problems at least. So here is a link that you see in our chat. That'll take you to the Zoom meeting, and they're both going to be running, so you can continue to have two windows open if you like. But whatever the case is, I'm just going to open that also. The midterm will just be taken at your house, and you just email me your answers. It's not going to be on Zoom, but I will send the test form to Titanium, and then you will create an email. Just type my name in manually to the email, my email address, r.fullich@fullerton.edu, and attach your email exam. So yeah, that's how it'll be next Wednesday. All right, so anyway, I'm opening the Zoom meeting. All right, okay, so I've got this open here. And let me take us back into the problem set that we were all looking at last time. So I'm just sharing the screen for a moment here. And what you see is this list of exercises in 3.3. Okay, so I just want to take another couple of practice problems in section 3.3 so that you guys get a sense of, reinforcing the procedure of using truth tables to judge whether two sentences are equivalent or not. Okay, so with truth tables to this point, we've learned how to use them to analyze individual sentences and then to determine if the individual sentence is logically true, logically false, or logically indeterminate. Now we're using truth tables to determine whether two sentences compared with each other are equivalent or non-equivalent. So we did problem A here last time. That's where we ended our class meeting, 3.31. Now I'm going to just go ahead and try and get us into the second problem here that you see written, which is 3.31b. Okay, so 3.3.1 problem B. Okay, so here is the problem that you see. It's right here in the shared screen. So we're going to create a truth table. Okay. And to evaluate a pair of sentences to see whether they're equivalent or not, we have to put the two sentences that we're evaluating here on the top right. So in this case, the first individual sentence is if A, then if B, then A. And then the second sentence in this pairing is either C and not C. You know what, actually, I'm sorry, I just want to slide this to the left a little so that I have a little bit better ease writing it. So 3.3.1b, and problem. Okay, so we said if A, then if B, then A. And then the second one says that either C and not C, or if not, it's either that, or A, if A, then A. Okay, so before I go to the left, top left, oh, and by the way, sorry, let me do one thing here. One second. Let me stop the share, get the chat going. For the midterm, can we turn it the same way we do for the homework? Yes, Leo, that's true. That's correct. I see you there in the chat. So I'm just pulling up the chat. Now the chat is open for me and for everybody else. All right, good. So one last thing, share the screen again. All right, cool. So I just need to have the chat displayed so that I can see your comments. I'm looking at the comments that are coming in on Zoom right now. I don't have my YouTube window open, so let's use the chat function on Zoom for the moment, if that's okay. All right then, so question now. I'm going to evaluate these two sentences here to see are they logically equivalent or not. To complete the truth table, let's continue by adding the downward facing arrows. So there's going to be two of them that face down over the main connective of these two sentences. So let's see in this chat, where shall the downward arrow be placed above this formula? It has to go over one of the connectives. But which one? Okay, good, Lily. It's the first arrow. Because this is a conditional sentence, and it cannot be this arrow because that's nested within the parentheses. So this whole thing is the consequent of this larger conditional, where this is the main connective. Okay, now over here on the right, what's the main connective of the second formula? It's the or. Thank you. Okay, so it's this symbol here. Now, we have got how many letters total in both of the formulas? We've got 3. And what are they and what order do they go in? So that I can fill this part in here on the top left. ABC, good. Okay, ABC. That requires a total count of how many horizontal rows? 8, correct. Okay, now, let us see if the two are logically equivalent. We start with A, and we do a 4x4 display here. Okay, so you see 4 T's followed by 4 F's. Okay. Now, next we have this situation: T, T, F, F, T, T, F, F. So again, because there are 8 rows needed on the leftmost column, where the first letter of this sequence starts, we'll see them displayed in the order 4x4. Where the top half are all T's and the bottom half are all F's. And then as we go to the next successive column, we just alternate at twice the frequency. Instead of 4x4 T's and F's, it's 2x2 T's and F's. And then finally in the column under C, the rate of alternation doubles again until it's 1x1. Okay, now we will fill in underneath A, B, and C in each row according to the truth value assignment given in that row. So in the first horizontal row, A, B, and C are all assigned true. So T is written underneath each case of A, B, and C in that first row. And if you kind of know that's one way of doing it, going horizontally left to right, the other alternative, which is in some ways faster, is to go vertically top to bottom. So we can simply go underneath each case of A and mirror the display vertically that you see here on the left. Again, 4 T's and 4 F's. That's true in each case where there's an A. Okay, and here's 2 more A's over here. And in each case where there's a B, the display vertically down is 2x2. So we show that here. There's only one B, but there are these 2 C's here. Underneath each case of C, we match this vertical diagram here. One more vertical column here. Okay, so now the T's and F's for the sentence letters are assigned. Next, we have to do each individual connective, saving the 2 main connectives for last. So since this is a little less complex, the left formula, let's do this column first. So I'm looking for the value to place in between these 2 letters in this vertical row. And keep in mind the connective is the conditional sign, or in other words, the arrow. So t leading to t, what's the truth value of the first position here in the first row? True, correct. Row 1, true. Row 2, as soon as you know, just let me know, and just say row number first if you don't mind. So in the second row, also true. Row 3, the value in case of row 3. No, Frida, not correct. True is the answer. Because it has to be, if it's F here, it has to be T on the left, F on the right. That's the only combination that leads to F. So F leading to T is T. T leading to T, T. F, F, still T. It has to be only one combination where T is on the left and F is on the right, if it's false. So here, row 4. Row 4. True again, yes, correct. Row 5. Row 5 is the case where it's false, correct. This one's false because T is on the left and F is on the right specifically. So whenever that combination is shown, that's when the arrow is F. How about row 6? Row 6 also is F, correct. Because yet again, same rule. TF, that's a false conditional. And then row 7 and row 8. Row 7, true. And last, row 8, also true. Okay, good. So we've done that column. Now let's just fill this part in here. So I'm needing two factors to put the value here, a left and a right term. The left term is obviously the value written underneath the letter A. But what's the right-hand term? It is the letter that's written underneath the arrow sign, correct. So now, using those two, T, T, what's the value in row 1? The true value of the arrow sign in row 1 is T. Okay, good. Tell me about row 2. What's that truth value? Row 2, also T. Row 3. Let's see it. Row 3, true again. Row 4. Row 4, true, yes. Row 5. Yet again, true, F to F, true. Row 6. How have I got those values, Jessica? Okay, the way that I've gotten those values is that I'm comparing these two components on the left and right. The information written under the letter A and the information written underneath this arrow. So when looking at that, you see a T and you see a T. The rule for the arrow is that it's always T, unless you have TF. So since none of these say TF, the value assigned is T in every case. F leading to F, still true. So the only time where the F would be placed here is if you saw T on the left and F on the right in those two positions. So anyway then, row 6, also true. Row 7 and row 8, let us hear that. No problem, Jessica. Yeah, true, true. So now, we finished this whole formula and we circle the column that falls underneath that arrow. But we now have to finish up this right side, which is still not complete. So let's begin on the left bracketed conjunction. This is a conjunction with C as its left term and the negation of C as its right. So since negation reverses the true value of its immediate component that it's attached to, this should be easy enough. Tell me what's the display going down under the tilde starting here. 1, 2, 3, 4, 5, 6, 7, 8 letters. Let me know. Frida, you say F for all rows, but no, because I'm not asking about the conjunction sign. I'm asking about the tilde sign. The tilde sign is attached to this, the letter C. So it simply changes the valence written under C in each case. So since this says T, to the tilde on its left, there's F. And so these other answers given are correct. F, T, F, T, F, T, F, T. So now, we have yet to fill in under the conjunction sign here. This conjunction sign has to use two elements, what's written under C and what is written under tilde. Now, what is the rule for conjunction? With conjunction, they both have to be true on the left and right. Otherwise, it receives the value F. So then tell me, row 1 should say, and maybe this is what you meant, Frida, that under the conjunction sign, it's going to be all Fs. That is accurate. Right here. F, 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 F. Why is that? Because in every single case of this conjunction, at least one of the left or the right, or even maybe both, are false. In the first row, the right-hand conjunct is false. In the second row, it's the left. And it seems that they alternate in that way. It's either the left one is false or the right. Now, we have to wait for the last connective at the end because it's the main connective. So we have to go here next. So what it says is if A, then A. And you see the truth values on the left and right provided here. So in all 8 of these cases, what should we see? All true, correct, Lily? Because it only takes one of the disjuncts to be true for a disjunction to be true. And in every single case, wait a minute, sorry, I don't mean disjunction. For a conditional to be true, all we need is anything other than T leading to F. And since these are both the same sentence letter, they won't have a T and an F. They've received the same assignment in every row. So 8 letters T. Okay, so now finally we have this disjunction sign. And with disjunction, you have to have at least one disjunct that's true, and that will make the whole disjunction true. But because on the right side, everything under the arrow says T, we don't even really have to consider the information on the left, because the right disjunct is true in all 8 cases, which means that this disjunction is also true in every case. So then, we will circle this column. We have our 2 main connective columns circled, and you see the display of truth values underneath. So now the question is this. Are these 2 statements logically equivalent, or are they not logically equivalent? Yeah, so Tanya, the question you had is about these. Yes, it would have to say TF for it to be a false conditional. But since they are all not showing TF, that's displaying the value that they're all true. And that gives us information that allows us to fill this column in. Knowing that the right-hand disjunct is true in every single case, the disjunction overall is true in every case. Wait, the V symbol? No, Tanya. When the V symbol is TF, it is true. The V symbol is only false when both of the disjuncts say F. So FF has to happen for a disjunction to be false. The reason these are all true is because this element on the right is true in every case. Noticing, though, that over here on the left you have F leading to T. It's not relevant the order. It's just the fact that there's a disjunct on the right that has the letter T. Okay, good. They're both logically true, but the question that I asked was a different question. Are they equivalent or not? They are both logically true. That's correct. Yes, they are logically equivalent. Exactly, yeah. They're logically equivalent because they are both logically true. They don't differ in truth value in any single case. So you have a situation of 2 formulas that are both logically true, and on that basis, they're both equivalent. Now, I'm just pulling up the answer key here for a moment to show you that. Can I slide this around? Sorry. Sorry, here it is. Wait, B. This is question B. Yeah. 3.3.1B. Oh, wait, no, these are the same ones. Sorry, just give me a second while I pull up the other Yeah, oops, A and A. So I need to go back to the, sorry, 1 second. I just pulled up the wrong answer key on one of these, so. Here we go. I've got it. So, yeah, so in this case here, logically equivalent, these are the two columns. It's the same as shown on our board, but there you go. Now, I want to do another problem really quick, and I want to show you guys another method by which we can assess equivalence or non-equivalence of two sentences in logic. So let's look at problem D here for a second. Okay, so there's also what is called the shortened truth table method. And I want to try and give you guys a sense of that. So problem D, underneath. We'll start off as before. We just draw this cross shape. And then we're going to put in the sentences to be evaluated. So the first one says both C and either B or A. Okay, C and B or A. And then the other one says C and B or A. Maybe my ampersand is just too messy looking. I'm sorry for that. So I just want to just do it with the caret thing. So for typing, it really doesn't matter. But for my writing on this board, I think it's a little clearer when we just use the little caret. So back to this, C and B or A. And then over here, C and B or A. Okay, so this is a conjunction where the left term is an atomic sentence and the right term is a disjunction. And this is a disjunction where the left disjunct is a conjunction and the right disjunct is an atomic sentence. So now, quickly, what are the two main connectives to place here? The arrows above. So first of all, this formula, what's the main connective there? And downward arrow should be above the and sign, yeah. And on the right-hand formula, downward arrow above the wedge, correct. So here we have yet again, how many sentence letters? There's 3, and the order is once again A, B, C. Now, what I'm about to show you is a shortened truth table method. So if the two sentences are not equivalent, if they're not equivalent, then that means by definition that there will be at least one row in the full truth table where this will say T and this will say F, or vice versa. For them to be not equivalent, then they cannot share the same truth value in every possible world. So if they're not equivalent, there will be one row when the table is complete where they will not coincide in that horizontal row in terms of their truth value. Now we can work backwards from the starting assumption that they are non-equivalent and then just try to plug in the truth value assignments in a way that will give us that result. So let's try that. Let's suppose these are not equivalent. The shortened truth table will only necessitate one row instead of the full 8. Will you have a problem where there's 4 letters? Yes, we'll get to that, Brenda, for sure. But for now anyway, let me stick with this. Well, we can definitely try a 4-letter example in a bit. Okay, so let's say this one was true and this one was false. Let's work backwards from that assumption, okay? Now, if this is true, if this conjunction is true, then what does C have to be? Lily, you're answering my question right now? Good. So if this is a true conjunction, then as we know by the logic of conjunctions, both conjuncts must be true. So that means we could then say this letter C is true. And whenever we add a truth value under one of the letters, we place it over here in the assignment table, which means that it's going to have to consistently be assigned across to every instance of C. Now, once again, if this conjunction is true, then this disjunction also has to be what? What should be the truth value of the disjunction on the right of the conjunction symbol? Good. Again, Lily and Yvette, that would also have to be true to sustain the assumption that this is a true conjunction. Now, if this is a true disjunction, we have got options. It could be that it's true because both A and B are true, or it could be true just because one of them is. But let's hold that thought for the moment while we go over here to this right side. Now, this is a disjunction, and we're assuming it to be false. If this disjunction is false, then what has to be the truth value of the letter A? The rules for disjunction, correct, Lily, and require that when a disjunction is false, both of its disjuncts are. So if this is false, we can then say that A is false, and also the conjunction here is false. Now, having given A the letter F, we simply do that consistently in each position where there's an A on the table. Now, this again we say is a false disjunction. And if it's a false disjunction, then it has to have a false left disjunct as well. Since C was given the letter or the truth value assignment true, the only way this conjunction will be false is if B is what? B basically has to be what? True or false? Correct, it has to be false. And then we will be able to replace over here in that way. But we've run into a problem. We've run into a problem, guys, because in this case here, the conjunction did not turn out to be true, because the only consistent way of plugging in values to generate the fact that this was false contradicts the truth value assignment given here on the left. So that's not the way that this shortened truth table could work. Maybe we have to try it the other way. So let's try again. We recreate the table as saw before, and now we're going to just, again, create this display above. Sometimes with a shortened truth table, your first attempt to kind of force it to have the values that you want will not work, and then you have to make a second attempt. So let's do it again, except now we're going to assume that they diverge in truth value for the other reason, that this one's false and this one is true. Okay, so now let's just try and play around with the values. If this conjunction is false, it could be false for what reason? Well, it could be false because the left term is, or because the right term is. Let's assume that it's false because C is a false conjunct. So we just then place the value F under C, and then again do that consistently throughout the row. Now, over here, we have a true disjunction. Why is this disjunction true? Well, it has to be true because at least one of the two disjuncts is true. If they were both false, then that could not sustain this truth value. So we've already given the value of falsity to the letter C. And that means that where C occurs in this conjunction, it's a false conjunct. So basically, this conjunction is already known to be false owing to the falsehood of its left member. Therefore, for this to be a true disjunction, what does the value of A have? The letter A on the right of that disjunction there is going to have to receive what truth value? Exactly, Ruby, Arlene, and Leo, and others. It has to be that this is a true disjunct. Because otherwise, if it was false, then both of the disjuncts would be false, and this would not be correct. So we've assumed now A to be true. And we will then reflect that in all of these cases where we see the letter A. So looking at this conjunction now, it's already good that it's false because C is false. We just have to make sure that this turns out true, but it is. Now B. I think it kind of doesn't really matter what truth value we give to B. That means that there's going to be two rows really on the truth table which will bear out this result. But let's just take the case of B being false. Okay, so we have a disjunct here that's false, and the other one is true, which means that that disjunction is true overall. Since this is a conjunction sign, the main connective, the left conjunct is enough to sustain the result we want. Now over here, on the right side, we've already given the assumption that B is false. So here we have B and C both false in this conjunction, so the conjunction is false. But when it's a disjunction symbol, we only have to have one member at minimum that's true, and we do on the right. So here we go. Question: are these two sentences logically equivalent or not? That's yes or no question for you. Good. The answer is that they are not equivalent. And how have we shown that? Well, we've just created the one row in the truth table which shows that they do have one case at least of being non-equivalent. Now, some truth tables will have more than one such row, which means that there's sort of like you're going to have multiple ways to create a shortened truth table, depending on how you choose to assign the values to the individual letters. All that it has to be is that they're consistently assigned and that they bear out the difference of truth values needed to display non-equivalence. So look, when they're not equivalent, it will be possible to create such a shortened truth table. But when they are equivalent, then you have to create the whole truth table, because when they are equivalent, there won't be one row where they don't match. And the only way of showing equivalence is by showing a full table where both completed columns are identical in all rows. Now, Leonard, you said if it did not work when we try it again, does that imply that it is either logically true or false? No, what's being evaluated right now, Leo, is equivalence. The concept of logical truth or falsehood is a different evaluation. If it didn't work when we tried again, it might just mean that they're equivalent rather than being non-equivalent. Okay, so if there's no way to consistently assign values which make one have the value t and the other f, then there is no such row where they have different values, and that's the reason it's not possible. So to answer your question, Leo, if it doesn't work on multiple attempts to create a shortened table, then it's a problem where the two sentences are equivalent. You can also do a shortened truth table, though, to show that a sentence is not logically false or not logically true. You would then, in that case, create a table for the one sentence and assume it to have the contrary truth value. Okay, like so, for example, here. Say that I have this formula right here. A and B and C. Okay? And my question is this sentence logically true, logically false, or logically indeterminate? And suppose that I'm just interested in the question, is it logically true or not? Is it logically true or not? Suppose that I'm interested in proving that it is not logically true. Okay, well, first of all, this is the main connective. Here are the three sentence letters that appear. I want to create a shortened truth table to show that this is not logically true. So if we work backwards from the assumption that it's not logically true, that means that at least one row in this table, underneath that arrow, will display what value. If it's not logically true, then there's at least one case where we should see F underneath that arrow. So let's assume that that can be done. From the presumption that this is a false conjunction, which way would you like to go? Assume what to be false, the conjunct. Let's get your suggestion on where to proceed from here. Let's say it's the left one. Okay, Leo, good. So if this conjunction is false because of A, then A is a false sentence. And I mean, now, is there a way of filling in B and C which preserves this result? Sure. And it's kind of just arbitrary. We can say that B is true and C is true. And then we would still have this result, that that's a row of the table where the sentence is false. We could have also assumed otherwise, that B is true and C is false. And we would have still had the same result. Even if we had assumed that B and C are both false. We would have still gotten the result that we want. So it's not logically true because of the existence of like 3 or 4 different rows in the full table where the sentence is false. So a shortened truth table can be used to show that a sentence is not logically true or not logically false. Now, if the sentence is logically true or logically false, then this cannot be performed, and you'd have to create a full table. And again, with equivalence, a full table is needed to demonstrate that they are equivalent, but a shortened table is possible to show that they're not. You don't need a shortened table to show that they're not equivalent. You can create a full table and then just circle the relevant rows where the values don't coincide. But this is just another tool, and it's mentioned in our textbook, so you can refer to those pages of the book also for any support in doing problems like that. Okay. So yet again, we are going to now try a truth table exercise to test one more property of sentences in logic. And so next, we're going to try and learn how to use truth tables to determine whether sets of sentences are logically consistent or not. So let me just open my book here to that exercise. Okay, consistency. So let's ask each other again, what does it mean if a set of sentences is logically consistent? Tell me the definition of that idea. If a set of sentences, now this doesn't need to be 2, it could be 2, 3, 4, however many, but if a set of sentences is logically consistent, this means that what? What does logical consistency mean? Possible for all members of the set to be true. Yes, exactly. So like when you guys gave examples in your homework, Kobe Bryant is still alive, Hillary Clinton is the president, and the Lakers are in the NBA Finals, something like that. Those are different sentences that all could be true. There's nothing about them that contradicts each other. So it's possible for all members of that set to be true. Well, what we can now do is use the tools of logic and truth tables to make a proof of whether a set of sentences is logically consistent or not logically consistent. So let's do that. Take, for example, let me get a good one here. Let me quickly stop sharing the screen as I look at something in my answer key. Just scrolling a little bit and finding a good example to work off of. Okay, consistent. That's a big one though. A little bit easier one. Sorry, 1 second here. 3.4. Okay. Okay. Okay, yeah, so let's do this one. So if you look in your book, sorry, now let me get the screen share back. My bad, 1 second. All right, so I'm looking here at some of the initial discussion on pages 92 and 93. Let's take a quick look at this set of sentences. So we've got A, that's marker, my bad. A, if B, then H, and then just B. Okay, so here's 3 sentences. We're going to create our familiar cross pattern. There are going to be arrows drawn down over, sorry, 1 second. Okay, so yeah, I can see the chat. There are going to be arrows drawn down over each of the 3 sentences. Now, if there's no main connected because it's an atomic sentence, then it's easy. You just draw the arrow of the letter itself. If it's a compound formula with a connective in it, then you'll find out which connective it is. This one's very easy. So where do the 3 arrows go? An arrow above what, and what? Just let me know those 3 items to place an arrow above. A, yes. The arrow, and of course B on the right. Okay. Now, in this case, there's a total of 3 letters, and we know their alphabetic order, so A, B, H over here. As with all truth tables, There's a set number of rows that are going to be required, and in a case where there are 3 letters overall and all the formulas being analyzed, it necessitates 8 rows. So that's what we do. Underneath the leftmost column, it's 4 by 4. In this column, it's 2 by 2. And in this column, it's 1 by 1, as usual. So like the beginning of setting up a truth table is just an algorithm. There's no originality, there's no creativity that you're allowed. It's just, it must be done in a precise way every single time. So there, that part's done. Now, as usual, we replace underneath every letter here the truth value that it gets in every horizontal row, and this would just show us that pattern. Now with B, we already know it's 2 by 2, so I can just draw the vertical column which shows that ordering. Now H is the one where it's singleton, TF, TF, alternating one at a time. So that's what we write. Now in this truth table, there's only one real connective in any of the sentences that are being analyzed, and it's this arrow here. So let's get back into our semantics for conditionals. I have to write 8 truth values in this sequence vertically going down. So in row 1, what's the value underneath the arrow symbol? Is it a T or an F? Row 1, let me know. I'm seeing the chat, so just when you're ready, you'll type it in. Row 1, what information is to be written there? Okay, good, T. I see a little hesitation. Everybody, conditionals. If it doesn't say TF, then it's true, that's all. So what about that one? Row 2, F, good, okay? That is the only way that the conditional is false. So unless you see a T leading to an F, it's true. But when you see that, that's the one case where it's false. So then, row 3. Do provide the row first, just to eliminate any confusion. Row 3, T, good. Row 4, also T, good. Row 5, true. Row 6, row 6 is an F, that's right. And then row 7, row 8. Row 7, true, both true, good. So now, we will circle the full vertical column that occurs under the 3 arrows. Now here's the question. We're not actually done just yet. We're asking this question. Are these sentences consistent? Yes or no? And the answer will depend on this. Is there a row, is there one of these 8 horizontal rows where each of the 3 sentences is true? Let's start from the bottom and work our way up. Row 8. Are they all true in row 8? Yes or no? Tell me about row 8 and answer that specific question. Are they all true in that 8th possible world, in that 8th truth value assignment? No, they're not. Why not? Well, because in that case, only this conditional is true, but the 2 individual sentence letters are false. So that's not a situation where they're all true. Is row 7 a case where they're all true? Again, no, for the same reason again. In this case, yet again, it's only the middle sentence, the conditional, that's true, but the 2 individual sentence letters A and B are false. So in the FFT combination, this is true because it's a false antecedent and a true consequent, but the 2 sentence letters, on the other hand, are both false. Okay, row 6, are they all true in row 6? And yet again, our answer is no, because in row 6, only this sentence is true, and the other 2 are false. What about row 5, going up to this 5th row? Are they all true in row 5? Close, but no. because in row 5, as you can see, this one's throwing it off. It's the one that's false, even though the other two are true. Row 4, still there's a problem. Not all of them are true in row 4. In row 4, B is the odd man out, and the other two are true. So what about row 3? Again, not quite there. True, true, but that one's false in that row. So row 3 is not the winner. Maybe I shouldn't use a colloquialism. It's nothing about winning and losing, but it's not the one where they're all true. In row 2, are they all true? Yet again, no. In that case, it's our conditional that's throwing off the truth of all 3. But in row 1, now we've gotten to something. Are they all true in row 1? Yes, they are in fact. So in row 1, since they're all true, we circle that row horizontally, and then we just write consistent. This set of sentences is consistent. It's consistent because there's one truth value assignment where they're all true. If there's even one such horizontal row where you see T, 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 where they're all lined up under those arrows and they say T in that horizontal row, that means that this is a consistent set of sentences. But if there's no possible row, no possible world where all of the sentences are true, like in all these other 7 cases, they're not all true, then that means that they're not logically consistent. So if we had completed a table like this and we could not find any row horizontally where all their values are true, then we would have written not consistent. And we would not have had such a horizontal circle because there wouldn't have been one row like that to circle. Okay, so now I'm showing you how to evaluate the question, is a set of sentences logically consistent or inconsistent? And therefore, let's go on. You see here, this is the table in the book. If you're looking at the screen, this is the table in the book that corresponds to what's written there on the board. Let's do another case then. Okay. So I'm going to try this one with you guys here. This set of 3 at the bottom of the page there. So the truth table can be used, as you guys are learning, to evaluate individual sentences to see are they logically true, logically false, or indeterminate. When that is the question the table is analyzing, you just look at the finished column under the one main connective, and you're looking for either all T's, all F's, or a mix. And that gives you the answer there. When you take pairs of sentences to evaluate them and see are they equivalent or not, you look at the 2 columns that are circled under the 2 main connectives in the pair, and you're looking to see do they differ in any one of the horizontal rows. If they ever differ, they're non-equivalent. And if they're the same in each case, then they are equivalent. Now, in the situation where we're learning about how to use tables to judge whether sets of sentences are consistent or not, that's what we're doing right now, then you finish the table, and when you look through it at the end, you're trying to see, is there any single row where all of the sentences are true? If so, then they are logically consistent, and if not, then they aren't. Okay, so let's try a new problem on the same material. Sorry, the black marker is a little better. Okay, so this is what's on the bottom of our page 93. Suppose we have C or not C, both not C and D, and then not D. Okay, so 3 main connectives to work with. What are the 3 main connectives from left to right that I will draw these arrows above? Blank, blank, and blank. Put those ordered connectives in the chat so we can all see those. Yes, the wedge, the and sign, and then the tilde. All right, good. Up here to the top left, we place the letters involved in their alphabetic order. And as you can see, there's just 2 letters in these 3 sentences, and the letters are C and D. So now this requires how many rows again? This one would yield a total of, since there are 2 sentence letters, we take 2 to the power of 2, which is 4. So underneath C, we have 2 by 2. Again, the rule is that however many rows are needed, the initial column that falls under the leftmost sentence letter is going to have the top half T and the bottom half F. Now under D, it's just TF, TF. Keep in mind why we do this. Just I want to keep it very clear to you. It's because we're trying to go through every combination that's possible of two facts, being either both true, one true and not the other, or both false. So like if I tell you that Trump and Biden are going to get coronavirus, that statement has 4 ways of playing out. It could be true because they both get it. It could be false because just Trump gets it, not Biden. It could be false because just, let's say Trump doesn't get it, but Biden does. Or it could be false because neither one gets it, right? So that's the possibility of combinations. If I say to you I have an apple and a banana in my bag, I might have just one, or I might have the other, or I might have both, or I might have neither. And so this shows you all possibilities concerning the true value of 2 randomly suggested statements or facts. So anyway, we continue to fill in the truth table here on the right. And it's just an algorithm. Underneath C, there's TTFF. And under every case of D, we have that displayed, TFTF, until the table is filled. Okay, so now let's just do it left to right. We can't fill this arrow in until we've got everything else done first. So what is to be placed under the tilde, left of this letter C? I have blank, 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 blank. 4 items. What's those 4 things under that tilde? FFTT, very good. Now, for the wedge, for the or, we have to use the left value and the value under the tilde. And using the rules for or, what is to be placed here? Blank, 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 blank. What are those 4 things going to say? True, 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 true. Good for you. Because in every single case of these 4, one of the things on the left or the right is true. In this case, it's the left side, right side, so true in all 4 cases. So one of our formulas is done. Now we move on to the next. We're going to save this arrow column for the last. So under the tilde here on the left, we have to have a blank, 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 and it's the reverse of these 4. So what's the display to be shown here under this tilde? Let me see that one in the chat. 4 truth values under that second tilde. What are they? Good, Kalaya. For FFTT. So as we now complete this part, this is a conjunction sign. And the rule for conjunction is they both have to be true, and if not, it's false. So using tilde and D, what's the value of the 4 things here? FFTF, good, Frida. False here because of the left conjunct. False here because of both the left and the right. True in this case because we have 2 true conjuncts. And then finally, false in the 4th column or row because there's a false one on the right. So now the second one is done. And the third is the perhaps easiest one to complete. We just have to know blank, 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 and blank under those 4 tilde. Under the tilde, what are the 4 values going downward? It's just the reverse of what's under letter D. So what we should see, good Melanie, is FTF. Circle that one. And now the question is this. Are these sentences consistent or are they not consistent? That's the question that ultimately you have to answer here. So are they consistent or not? Good, Lily, they are not consistent. Why not? How is it seen? It's seen visually. It's seen visually by the absence of a row where everything is true. So let's just go through the rows one by one. Here's row 1. Are they all T? No. T, F, F. There's 2 out of 3 that are false, so it's not all true. Row number 2. Well, this formula is true, and this formula is true in that assignment, but not this conjunction. So there's one false one. Row 3, again, they're not all true. These two are, but not that negation. And then finally, in the 4th row, this one is false, even though the other two are true. So you can't find one row on the table where circling horizontally under the main connective, you're going to see everything being true. That means they're not consistent. These 3 sentences cannot all be true. They're not logically consistent. And let me just try and think of like a logical explanation of that. So like say that D stands for I have a dog. C stands for I have a cat. So this is either I have a cat or I don't. That's logically true, so that's always true. This stands for both I don't have a cat and I do have a dog. Well, if that's true, then it must be a situation where you don't have the cat and you do have a dog. So that's only true in that one case. But if we look at the final statement, which says I don't have a dog, that's only true, right, on a situation where it's false that I have a dog. So they can't all be true in the same situation. This being true eliminates the possibility that this is true. For this to be true, D has to be false. But whenever D is false, this conjunction can't be true. So the statements can't all be true at the same time. They logically contradict, so they're not consistent. And so that's how one can use a truth table to evaluate that status of a set of sentences. So far, what I've shown you today is just one example of a problem where the sentences were consistent. That was the one here that I'm using the cursor to point out on the screen share. And then this one here that you see below is one where they are not consistent. When there's not a consistent set of sentences, there won't be any horizontal row to circle in the end. Okay, now let's do another little exercise with the shortened table method. The shortened table method, as I showed you, can be used to show that a sentence is not logically true or not logically false. It can also be done to show that a pair of sentences are not equivalent. Just create the one row which displays that they have different truth values. Well, consistency can also be shown by means of the shortened truth table method. And I'll just quickly try to show you how that one would work. So now consider these two sentences. For the exam, do we need to use it? No, Evelyn. Well, I shouldn't say no. If you need to use it on the exam, I'll make it specific. I'll say create a shortened truth table to indicate that this pair of sentences is not equivalent or something. But if I don't make a specific instruction like that, then no, you won't be asked to use it. And in some cases, it's not possible to use it. It's only possible to use it when there's a specific kind of answer, like this is not logically false, not logically true. These things are not consistent, or sorry, these are not equivalent, or they are consistent. To show that they are equivalent, you have to have a full table. To show that they're inconsistent, you need a full table. To show that they're logically true or logically false, you also need a full table. So only certain results can be displayed by means of the shortened method. And yes, as you've asked, if and when you're going to have to perform a shortened method table, then I'll direct you to the that specific requirement on a problem. But in general, it's optional. Okay, so one more little look at this. Take these two statements. E triple bar H, if and only if E. And then the other statement, let it be just H and not E. All right. Now, triple bar is equivalent to the double arrow, just to avoid any kind of confusion. And I guess because you can't really draw the double arrow too easily in the chat, since you can't draw the triple bar too easily, I'm going to just use the double arrow. But either is fine according to the conventions we're using in class. So let's assume that these two sentences here are not consistent with each other. Not consistent. Sorry, strike what I just said. I meant to say, assume that they are consistent with each other. If these two sentences are consistent, here's the main connective in the two cases. If this is a consistent set of sentences, then what will appear in the truth table in at least one of the horizontal rows. If they're consistent, then there has to be a row where they're both what? True, exactly, Lily. So let us work backwards from the assumption that there is such a row and see if we can create a table which just has that one row. So assuming that this is true and this is true, we will now have to work backwards. Let's go on the right because that provides more clear direction forward. This is a conjunction. If we assume that this conjunction is in fact true, then what has to be the status of H? H, correct, Lily, has to be true because if this is a conjunction must have two true conjuncts. So H would have to be one of those. Sorry, over here, EH. Now, having already made that assumption that H is true, we have to do that consistently in every case of this horizontal row. Okay. So still here, this conjunction, we say that the left conjunct has to be true, but so does the right one. And the right term is the negation. But if the negation is true, then what has to be the value of E on that right term, on that right conjunct? For negation E to be true, E must be false. Exactly. Now that we've assigned the value of false to E, we then have to do that throughout consistently. And let's see if this works. So false, true does yield that this is false. But since this biconditional is false and the right element of it is also false, this is true. So we've done it. We've created a horizontal row which does consistently show that these two statements could be true. And if they could both be true in that one truth value assignment, then yes, these sentences are what? Consistent or not consistent? Let me get the answer from you. Are they consistent or no? They are, exactly. Thank you. Consistent, why? Because we do have that row where they're both true. Now, a full table could have been created to give you the same answer, just a little more work, I guess. So like, let me begin again and show you how the table would have looked if we had just done it the old long version. So to complete a full table, we got 4 rows, T, T, F, F, written underneath E, T, F, T, F, written underneath H, and then we mirror that throughout the table. Okay, so this is a full table, and we just have to work with each horizontal row. So here we have a biconditional where the two things are true, and also here where they're both false, which makes it true. But 2 cases of a mismatch, so that's false in those 2 cases. Now, this biconditional sign looks at the information under the double arrow and the letter E, and they got to match for it to be a true biconditional statement. So true because T and T, false because F and T, true because F and F, and finally false because T and F. All right, there we go, circled that. Over here on the right, we have this conjunction, and the left side's filled in, but not on the right. Under the tilde, we're going to have a reverse of T, T, F, F, so that's F, F, T, T. And now to fill in this conjunction sign, it's false in every situation unless there's 2 T's. So that means F, because there's an F. F is both. True here, because the 2 conjunctions are true in that case, false on the bottom. So we circle that. Now, which row is the one where they are both true? If we number them 1, 2, 3, and 4, which row is to be circled here to demonstrate that they're consistent? It's the not 4th row, actually, Frida. It's the 3rd, yes. That shows that they are consistent. But the previous problem that we did just before this is the same problem, except we only had to create the 1 row working backwards from the assumption that the two propositions are true. So just letting you know that when they're consistent, a shortened table can be generated. But if they're not consistent, then the shortened table will not be possible. So, sometimes you can try and make work a bit shorter by doing that, but if it's not going to work out, then you'll have to create a full table, and you'll get the opposite answer, that they're not consistent. Okay, so there's only one more truth table concept that I'm going to teach you guys on Wednesday. That is how to use truth tables to determine whether an argument is valid or invalid. And then after that, we've completed all of the truth table material, and then we just start to review for the upcoming midterm of next week. The midterm will cover basic concepts of logic, like what we had in the first homework. It'll also cover symbolization and translation that you've had in the last homework that you just turned in. And there will be, I think, at least one problem or so on the truth table information that you're learning now. So that'll all be placed in the study guide. We'll go over it as we review for the test. And that's kind of the layout of the next week and a half. But I don't know. I don't think I can really rush the discussion of a new concept with limited time that we have. But if you want to do some practice problems to get yourself even better, the problems in 3.2 are the ones about logical truth, falsity, and indeterminacy. The problems in 3.3 are the ones about equivalence or non-equivalence. And these practice problems in 3.4 are all about the current question having to do with whether a set of sentences is consistent or not. So, feel free to use some of these practice problems to practice and get a little bit better at this kind of stuff. And the starred exercises here should have answers supplied in the Logic Book online resource center. I don't know if anybody has access to that, but if you go to find the Logic Book on McGraw-Hill's website, if you have your login information, then you should be able to get to those. And then that would at least help guide you through some of the problems that are in the book. Okay, guys, well, any other questions for now, I guess, for today's meeting? Let me know if there are. If not, I guess we can probably just adjourn for today. But let me get some feedback either way. I'd just like to know. If you're okay and this is good to go, then we'll just wrap. What do you say? If there are questions, comments, or anything else that I failed to mention, let me know. Okay, so Brenna. Will the midterm have to be completed within our class period? Yes. So the midterm is timed. Therefore, it does happen during the period of time that our class period would occupy. So you'll be given the test form at the class period at 11:30, and then I'm going to give you until basically the expiration of class time to finish it, so an hour and 15 minutes. So yeah, it is in a timed format, but you'll have your notes, so you have every opportunity to be well prepared for it. No problem. Thank you for that question. Everything's good then, guys? We're all on the same page? Will the test be taken through Titanium? No. The test, you're just going to do it on your computer and your word processor, but I will send you the test form through Titanium as a class-wide announcement. So you'll receive this class announcement. Just keep your browser open and be ready to receive the test form. Then you'll open the test form, create your answers, and then send me the file containing your answers as a separate email in an email attachment. The same way that you have sent me your homeworks, that is how you will send me your test. No problem. Okay. So far I think we're good to go then. Yeah, and don't worry too much. The test is not coming up this week. It's next Wednesday. So you've still got a little bit of time to work, and we're going to review also. Can you write the midterm on a paper? Sure, you can do that, yes. As long as you're capable of sending me a scanned image or some type of photo, I'll definitely accept whatever format, as long as it's properly delivered and I can open it. Okay then. So awesome. I'm glad that I could answer you guys' questions and help you through a little bit more material. So be ready on Wednesday. We'll go over more truth table stuff, and I'll send you guys a study guide for the midterm review in the coming days over this next week. All right, thanks guys. Have a great one. I'll see you soon. Bye-bye. All right. And signing off of this stream. See you. Bye-bye.